We'll turn it over to you, Fuad.
Yeah, hey everyone, my name's Fuad, and this summer I did tree inventory for the town of Halton Hills. And my capstone will be looking at how species and land use types affect the tree health. So overall, cemeteries have been neglected as contributing to the urban forest until pretty much quite recently, actually. And despite surveys showing that people actually want more trees in the cemetery due to things like nobody wanting to pay for them, space being needed for more graves and historic monuments, as well as environmental concerns due to the caskets polluting the groundwater and soil, it just can't happen. So as I mentioned, studies on facilities and cemeteries are both very limited. And this will be the only, I couldn't find any study comparing land use, like comparing parks, cemeteries, and town facilities all in one study. So yeah, this is the first. All right. So for the tree inventory, the first thing we would do is obviously ID the tree species we want to inventory, and then measure the DBH. And then we would give the tree a health condition rating on a scale of 1 to 5, with 1 being excellent condition and 5 being death imminent or already dead. Yeah, I know it's a little like confusing. One is the best and 5 is the worst, but I didn't make the system. Yeah, and following that, we would enter the tree as a GIS point in the town system ArcMaps. So for my statistical test, I use RStudio, and the statistical test was ordinal regression because tree health condition falls into ordinal categories. It's either 1, 2, 3, 4, or 5, no in betweens. And then these models, actually in terms of the ordinal regression, I will be looking at how species affects health condition, how land use type affects health condition, and how size, which is related to age, affects the health condition, and as well as many interactions between them. And lastly, these models were then put into an ANOVA. So what I predict is that maples will do worse overall due to species with thin bark, such as maple, will do worse overall because of the bark, and they have cellular roots as well, which make them more prone to lawnmower wounds. Whereas far adapted species such as oak, pines, and black walnuts will do better due to thicker bark and deeper roots. In terms of land use, I expect cemetery and park trees to do worse overall because of soil compaction from heavy equipment to maintain the park structures, such as playgrounds and baseball diamonds, as well. And in the cemeteries, there are excavators to dig graves, so lots of potential soil compaction from those. And I expect facility trees to do better overall because in a facility, you don't expect people or their dogs to walk on the grass. They go straight from the parking into the facility, so not as much soil compaction from foot traffic or like possible negative effects of dog urine either. Now on to the results. So in terms of how species affects condition, I had a sample size of 4,971, which is pretty much all the trees in the inventory except those that could not be entered into the GIS system. I mean, they could be entered into the GIS system, but they didn't have a name assigned to them because they're either very rare or invasive, like buckthorn, for example. I did not include buckthorn in the analysis. So yeah, anyway, so these results were statistically significant, with P being far less than 0.001. And while there were some differences, all trees were in pretty much good health condition, except for Austrian pine, which I attributed to a smaller sample size. There were only like 30 or 40 Austrian pines in the inventory. There's green ash, which also did slightly worse, but that was expected due to emerald ash borer. And yeah, these are just I couldn't fit every single tree species on the graph, so I just included those with more than 30 individuals in the inventory. Now, looking at land use, these results were also statistically significant. However, the magnitude is like really small. So yeah, so I was actually wrong. Trees and parks actually ended up doing better than they did in facilities. This could be because of the care that the town puts into their parks. And yeah, as you can see, these differences are actually very small. Like I think it's a difference of approximately 0.1 on the health condition scale, which is pretty much nothing, considering that the data goes in ordinal categories, either 1, 2, 3, 4, or 5, no in between. So 0.1 is like really not that big. Now, looking at the land use species interaction, I had to filter my data set once again and decrease the total sample size because since it's an interaction, I wanted to only include species with the bigger data set, so more than 30 individuals per species. That was the cutoff point I used. And yeah, these results were also statistically significant. However, I was wrong in that maple trees ended up doing worse in facilities than they did in parks, which again could be attributed to the town actually caring more about trees in parks. As I mentioned, cemeteries and facilities are often neglected. And I was correct in that certain species like conifers such as pines, oaks, as well as black walnuts did end up doing better in parks. So here you can see most of the maples did worse off in the facilities like sugar maple, red maple, which was not expected, but yeah. And then some of them did better in parks like white pine and oaks, and they ended up doing worse in the cemeteries, which could be attributed due to their age, which I will talk about next. So looking at the size variable, we decided to use something called DBH class, which I will explain in the next slide. So looking at how, and again, the sample size has been sampled, has been cut up, has been sorted, or like filtered. I filtered the data set again to have a smaller sample size because DBH is such a variable like data set. There's so much variation in the DBH. I only wanted to look at species, which included now more than 100 individuals in the inventory. So DBH on its own was statistically significant. However, when you factor in the land use type interaction, the results are no longer statistically significant. And then when you factor in the DBH class plus the species land use interaction, the results are once again statistically significant. So, okay, here's how we did DBH class. It's hit intervals of 10. So 0 to 1 would be 0 to 10, 1 to 2 would be 10 to 20 centimeters, 2 to 3 would be 20 to 30, and so on. And then at the 100 centimeter mark, we cut the data off, and every tree above 100 centimeters would go into the final category of the 10th interval. So as you can see, a lot of the younger trees are in parks, whereas a lot of the older trees are in cemeteries. And here you can see as the DBH class increases and the trees get older, the condition rating goes up, which actually means that as the trees age and grow bigger, the condition worsens. And lastly, I decided to look at a linear model to observe the sum of squares. And it turns out land use, while statistically significant, only explains about 0.17% of the variation. And for context, species and DBH class individually both explain approximately 1.9% of the variation. So on their own, all these variables do have a significant effect. However, land use is not significant when other variables are added. Now, what could this mean for the town of Halton Hills? So we should remove lawn grass near the trees or apply mulch in order to deter the lawnmowers and to prevent lawnmower wounds. Exposed roots should also be covered with a thin layer of sand or topsoil, again to prevent lawnmower wounds. There should be a metal guard at the base of the tree to prevent strimmer wounds, which, in case anyone doesn't know, is also referred to as a weed whacker, I heard. But yeah. And well, I also think they should consider soil amendments such as biochar and biosolids to improve soil growth as well as the quality of the soil. And improve soil quality and tree growth. And last but not least, they should also monitor the soil for compaction and nutrition deficiency and provide nutrients and soil aeration as needed. There's also the concept of like finding the right tree for the right site. However, my external supervisor, Catherine, who couldn't make it, is an ISA certified arborist, and so is the tree planting coordinator, Eric. He's also ISA certified, so I believe they're already focusing more on that. And speaking of, I would like to thank my co-workers from the town of Halton Hills, Mindy and Solid, my fellow interns, who helped me with the inventory. I would like to thank Eric Johnson from the town of Halton Hills, who's here on Zoom with us, for helping me with tree ID. I would like to thank Dr. San Thomas for helping me with the data analysis. And last but not least, Catherine Edwards from the town of Halton Hills for allowing me the opportunity to work with them.
Okay, thanks very much. So we have external supervisor from the town of Halton Hills, Eric Johnson. Does Eric have a question?
Yeah. Hey, Fuad. I just want to say thanks for all your work in the summer and doing all the inventory for us. It was great, and you did a great job for us. I was wondering, maybe in the future, if you wanted to further your study in terms of facilities, you could probably break that down even further into, say, fire stations or police stations, recreation facilities, community centers, things like that. Do you think you would find any significant trends if you broke down facilities even further, or do you think it wouldn't really matter?
Yeah, I actually think it might be because like I know that I see the public works while I was doing the inventory, I saw the public works guys more at some places than others. So I guess it would depend on how much the city actually cares or the township actually cares about that property and how much maintenance is being done on it. So yeah, I believe there could be differences.
Awesome. Thank you.
Okay, thank you, Eric. I guess I'll hand it over to Sean.
Really nice job, but I appreciate you made nice addition of work on your own with the statistics. So that's great to see. You're making use of this big data set so you can find these kind of small effects, which is exciting to have statistically significant results. But I do, wonder what you think about the tree health metrics themselves and whether there's, other kinds of observations that could be made that would give better insight from management, because just this is a very rough kind of measurement of tree health and maybe easy to implement, but it's not, you really, if the problems are coming out from strimmer or weed whacker effects, you want to know that, or if it's some other kind of impact, you really, you might do a much better job of detecting problems if your observations on tree health were better. And since you spent the whole summer making these measurements, what your ideas are on how you can do a better job.
Yeah, so this was actually their first ever inventory. They did not have one prior to me and Mindy doing it. So yeah, so it was obviously like not that in detail as compared to what Toronto or Mississauga do. However, yeah, I believe we could also look more at tree wounds directly, soil compaction directly. What I did was mostly infer that these kind of things could contribute to the overall decline of the tree. But yeah, I believe we could look directly at certain metrics, including wounds, compaction, chlorosis, ground dieback, all of that.
Thank you.